Hi guys and welcome to this, our modules walkthrough for the 2019 Northern Hemisphere Mathematics exam, Exam 1. My name's Darren Maths Guru, really good to see you. Thanks very much for following along. As you can see along the bottom are question indicators to let you know which questions I'm working on. And on mathsguru.com you can actually view individual questions. You can bring up a screen that shows you the question and then you can have a go at your answer yourself and then you can look at the solution, work solution. Mathsguru.com, absolutely free to sign up. Loads of stuff on there for you if you find it useful. All right, let's have a go at the matrices section. Now, obviously not everybody does matrices, and so again, you can fast forward to the particular module I am working on, or you may have completed for the 2019 exam. All right, question number 1, the number of individual points scored by Rihanna, Susie, Tina, Ursula, and Vicky in the 5 basketball matches is shown in the matrix below. Awesome. Who scored the highest number of points and in which match? So firstly, I'm going to look through and say, well, okay, which is the highest number? And it would appear to be 8. Now what I'm going to do then is decode what they stand for. So the player is here, so R is my player, which would be Rihanna. And match J would be here. So R and J, which would mean Rihanna. In match J, give me E as my correct answer. For question 2, 4 blue teams. Try that one again. 4 teams, blue, green, orange and pink, played each other once in a competition. This is important information, right? Because if they played themselves once in a competition, they can't play each other. They can't play themselves. And when one person wins, the other person loses. That would be sort of the general idea of what this question's about. There were no draws. The results of the competition are shown in the matrix below. The letters V, W and X. So we've got V, W and X. Either have a value of 0 or 1. 1 in the matrix shows the team named in that row defeated the team named in the column. That's also important. And 0 dash the rest of the... Right, so basically with these questions here, what we realize is, or what we know is that there is a symmetry here. Now I don't mean a like for like symmetry. What we can do is we say, well, if I look at, for example, this number here, B versus G, we also have a B versus G there. So rows and columns, columns and rows. And what we notice is they are the opposite to each other, because if B beat G, then G lost to B. Okay, so one's got to be a 1 and one's got to be a 0. So ideally then we need to look at our opposite. So that is symmetrical to there. So that would suggest that V has to be the value of 1. So automatically I can discount those two solutions there, or those two examples of answers. W would have to be 0 because it's the opposite, all right? So W would have to be 0, and in fact there is only one answer where that is actually true. And my answers in front of me tell me that C, in fact, was the answer that the examiners accepted. Question number 3, in matrix A, the element A2, 1 equals 7. The order of matrix A is a 3 by 2. Okay, matrix B is the transpose of matrix A. So matrix B could be. All right, so first things first. If order A has an order 3 by 2 and it's transposed, then B is going to be a 2 by 3. All right, so 2 rows, 3 columns. All right, so it can't be that. Right, so 2 rows, 3 columns, it's got to be that one there. We don't actually know the elements, but what we do know is that we don't know all of the elements, but we do know one element here. A21 is equal to 7. That's in the original matrix, which tells me that A12, because if you remember rows and column swap, would also have to be 7. So we're looking for the first row, second column. First row, second column. Is that a 7? Nope. Is that a 7? Yes. Is that a 7? No. And in which case B would have to be my correct answer. Question 4. In a game between 2 teams, Hillside and Rovers, each team can score points in 2 ways. The team may hit a full or the team may hit a bit. No idea what that's talking about. Is that a real sport? Who knows? More points are scored for having a full than for hitting a bit. A team's total point score is the sum of the points scored from hitting fulls and bits. The table below shows the scores at the end of the game. Let F be the number of points scored by hitting 1 full. Let B be the points scored by hitting 1 bit. Which of the following matrix products can be evaluated to find the matrix F, B? So the number of points scored by hitting a full, and the number of points scored by hitting a bit. So the first thing I'm going to do is write out 4, 8, 5 and 2. The reason being is because we know that these are the fulls and the bits. All right, so that's my full and that's my bit. So let's see where that takes us. And what we know is when we multiply that individually by F and B, which is the number of points, that is going to give me a total of 52 and 49, right? Because we know that we've got 4 fulls for hillside, so 4 times that, and 8 bits for full side. That will give me the total number of 52 for them. Yep, and if I did 5 times F and 2, right. So how do we then solve this question? Well, what we're trying to do is we're trying to find FB, which means we effectively need to do some inverse matrix stuff, right? So matrix division, not that we're allowed to do matrix division. So what we would then need to do, he says, is rubbing this out, is my suggestion would be we would have FB on its own, which would be given as 4852 to the power of minus 1 times 52 and 49. So 4852, I reckon A is the correct answer. I mean, in fact, it's the only one that matches my solution. And again, the order of this is really, really important. This is where that matrix algebra comes in, and A actually turns out to be the correct answer. A population of birds feed at 2 locations A and B on an island. The change in the percentage of the birds at each location from year to year can be determined from a transition matrix. Love transition matrix. In 2018, 55% of the birds fed at location B. In 2019, the percentage of birds that are expected to feed at location A is, right, populations of birds. The change in the percentage of bird location can be given by, right, so let's see, we've got 0.8, 0.4, 0.2, 0.6. So this is from one year to the next. In 2018, 55% of the birds fed at location B. All right, so what we need to do is I'm going to have my percentages of birds in 2018 in this one here. So they've told me that 55% of birds are at location B. And remember, because this order is important, A, B, that has to be A and B as well, which gives me 45% there. Right, so what does it want? In 2019, the percentage of birds that are expected to feed at location A. So we've got to multiply those two together. So what I'm going to do is lean over for a moment and fire up my CAS calculator. So menu, nope, wrong one. Let's try this one. That one, what do we want? We want that, please, and 0.8, 0.4, 0.2, 0.6. I really should become left-handed. It would make my life a lot easier, particularly when trying to do this. Multiply that by, what was it, 45 and 55, and go ka-ching, and there we go. So we would have got the answer as 50, sorry, he says writing 48, 58, and 42. And remember that A is the one we want. Yes, the percentage of birds expected at A would be 58%. And then as far as I'm concerned, for question number 5, D is the correct answer. And as it turns out, that was the correct answer. Matrix W is a 3x2 matrix. Matrix Q is a matrix such that Q times W equals W. Well, basically, for anything times by a matrix and be that same matrix, it's got to be an identity matrix. No way you could, because remember, an identity matrix is like multiplying by 1. So, matrix Q could be, well, because it's a 3x2 matrix, we've got 3 rows and 2 columns. All right, so to be able to multiply that, matrix Q could be, well, firstly first, it can't be A, because we've got here a 3x2. So to multiply that by anything, remember, to be able to multiply, those middle 2 numbers there have to be the same. So this thing here has to have 3 columns. Right? It has to have 3 columns. So that can't be that one, it can't be that one, and it can't be that one because that's only got 2 columns, right? See how they're trying to trick you there with 3 rows. So it's got to be D or E, but likewise, as I said before, it's got to be an identity matrix. And we know that identity matrices have 1s on the leading diagonal, 0s everywhere else. So for question number 6, D is the correct answer. All right, so question number 7. What have we got? Cows on a farm are free to be able to move between 4 water sources. P, Q, R, and S tend to be those water sources. And that's a transition diagram, okay? That's gross, but anyway. So what they then go on and do is they tell you, well, you've got information about week 23 of 2019 or week 24 of 2019. This question is tricky because it actually goes backwards. Oi, oi, oi. So of the cows expected to be at Q in week 24, the percentage of these cows at R in week 23 of 2019 is closest to. The percentage of these cows at R in week 23 of 2019. So actually we're going backwards. We're saying, well, how many cows, firstly, go from R to Q? So how many cows go from R to Q? There's 20%. So if we read that diagram, 20% of those cows who were here were at R. So 20% of these cows who are here have moved to Q. So if I now work out 20% of 240, well, I know I can probably do that in my head. 10% is 24, 20% is 48. So 48 cows moved here. But because they want to know what percentage of the cows who are at Q, I need to do 48 divided by 222, and I'm going to times it by 100. And as you can see on my screen already, I've already worked this question out. So 48 divided by 222 is 0.216, whatever it is. Times that by 100, put into percentage, it says, and because it says it's closest to, that's closest to 22%. So D would be my answer, which actually happens to be the correct answer. Okay, so for question number 8, sheep on a farm are also free to move between the 4 water sources. The change in the number of sheep at each water source from week to week is shown in that matrix. In the long term, now the trick here was the words long term, 635 sheep are expected to be at S each week. Now, in the long term, what we're saying is if I have my matrix, an S, we're looking at this value here. All right, now that's the long term, and I'll explain what that means in just a moment. All right, so in the long term, the number of sheep expected to be at Q each week is closest to. All right, here we go. So in the long term, 635 sheep are expected to be S. So first thing I'm going to do is long term means raise this to a high power. So if you see on my calculator, I've already put in my matrix. I'm going to call it A, and I'm going to raise it to the power of 50. A to the power, oh, he says not, apparently. A, we can do it, A, thank you, to the power of 50. Hit enter, and there we go. So there is my transition matrix. And again, what I'm going to look for is, he says, doing this big value here, is S to S. So what they're saying is each week, roughly speaking, 0.31296 times the total number of sheep. So remember, this here times my total number of sheep, which is, is going to give me 635. So what I now need to do is use that calculation. So 0.31296 times, let's call it S, is equal to 635. Now when we actually then divide that, so let's do 635 divided by 0.31296, gives me about 2,029 sheep in total. Right, so we know there's 2,029 sheep in total, which means that we can use that information now to get the expected number of Q each week. How are we going to do that? Well, what do we need to do? So we got P, Q, R, S, P, Q, R, and S. So we are looking for that figure there, which when I look on my thing gives me 0.26027. So now what I'm going to do is 0.26, what did I say, 027 times 2029 gives me the value of, let's do that now, what is it, 0.26027 times by 2029 gives me 528-ish, and so C would be my correct answer, 528-ish. All right, so again, we are looking at the fact that this value here multiplied by our long-term number of sheep is going to give me 635, because that's the percentage, yes, that we're going to be using. All right, moving on to Module 2, Networks and Decision Matrices, or Mathematics, he says. Question number 1, the graph below shown has 5 vertices and 8 edges. How many of the vertices in this graph have an even degree? So an even degree are basically the connections coming off of it. So that's got 2, 1, 2, 3. Now this is a trick. Remember that a loop counts as 1 edge, but it does count as 2 degrees. All right, so that would be 4. That would be 3. 1, 2, 3, 4. So let's count them up. 1, 2, 3 in total, giving me D as my correct answer. Consider the graph below. Euler's formula will be verified for this graph. What values of E, V, and F will be used in this verification? All right, so very fat elephants equals 2. So I want the V, E, and the F. V stands for vertices. So 1, 2, 3, 4. There are 5 vertices there. How many faces are there? 1, 2, and you've got to count the 3 outside. And then edges, 1, 2, 3, 4, 5, 6. So E, V, and F. Now they're trying to trick you there because they're trying to give it to you in a strange order. So E, V, and F. We'll be looking for 6, 5, and 3, giving D as my correct answer. Oh, let's zoom this one in. All right, 4 students, Alice, Brad, Charlie, and Dexter, are working together on a school project. Ouch, this project has 4 parts. Each of the students will complete only one part of the project. Table below shows the time taken for each student to complete each part of the project in minutes. All right, the parts of this project must be completed one after another. Which allocation of students to part must occur for this project to be completed in the minimum possible time? Oy, 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 oy. So let's just see whether we can do this by inspection. Brad. So there we go. Those people there are the smallest number of times. Okay, so obviously Brad and Brad can do part 1 or part 2. Alice part 3. Charlie part 4. Dexter's next smallest one would be 4 minutes for that one. Okay, so just by inspection, it would suggest that if we want to do this in the minimum time, so looking at this then, we see that part 3 has to be done by Alice. So I'm just going to highlight anything that's got part 3 in it with Alice. Part 4, Charlie. So part 4, Charlie, we're sticking there for the moment. Part 1, Dexter. Part 1, Dexter, it seems to be the only one there, and Brad would be then left with, I mean, Brad could do part 1 or part 2, but Dexter, realistically speaking, can only do part 1 because he's got to do it in the shortest, which gives me D as my correct answer. Now, in that one, I'm sure people would have sat there and tried to do the Hungarian algorithm. Sometimes, particularly for question 3, which is supposed to be a lot simpler than the others, inspection may also work. Question number 4, which one of the following flow diagrams shows a cut that has capacity of 19? Oh, okay, so cut that has capacity of 19. So first things I've got to look and make sure that my source and sink are all in the same direction. They are, and so it's important to look for arrows that are going from the left-hand side of the dotted line to the right-hand side. So there is, that is, that is, that is, and that is. So if we add together all of those together, we can get 5, 6, 7, 14, 21, that gives me 31. So it's obviously not going to be A. Let's try again. So that one counts, that one counts, that one counts. Oh, the 10 in that situation doesn't count because the arrow would be going from the right to the left. So 5. So now we're going to add all those individual capacities. 5, 6, 7, 7, 14. That would be giving me 21. Nope. Let's try again. Okay, so yes, I wouldn't include the 7. I would include that 10, but I wouldn't include that 7. Because the arrows are going the wrong way. 10, 11, 12, 17. Which one are we actually looking for? We're looking for 19. Keep going. Notice again the highlighting I use. I use my highlighting to make sure that it makes sense. All right, 5, 6, 7. That gives me 14. Wouldn't you just know it's going to be the last one? Hopefully. 5, 7, and 7 gives me 7, 14, 15, 16, 17, 18, 19. Which gives me E as my correct answer. So what was that? Question number 4, E, which is the correct answer. Question number 5, in the graph below, the vertices represent electricity transformers substations. Whew. The number on the edges of the graph show the length in kilometers of cables that connect these substations. What is the minimum length of cable in kilometers that's necessary to make sure that each substation is connected? All right, so again, you can start at any vertex, and I'm going to start here, and you take the smallest. So there we go. So I'm going to use, I think it's Prim's algorithm, if I remember rightly. So having got there, I now look at the ends of those. I look at each of my vertices and go, well, where's now the smallest? So that would be 8. I look there and I go, well, okay, which is now the smallest from all of those? I've got an 11, oops, he says, drawing. I've got a 10, but I've got a 9 here. So I'm going to do that 9. Keep looking around. Every time I connect a vertex, look for the smallest. That's going to give me that 7 there. Where do we go then? Right, I've got 8, 11, 11, 10, 14. So it's going to be an 8. Then what I've got an 11. So it'd have to be that 10. And then finally that 7. So using those, I'm now going to do 11 plus 9 plus 8 plus 7 plus 8 plus 10 plus 7. All right, so let's do this. 20, 28, 28, 29, 30, 35, 43, 53, 60. Damn, there isn't a 60 on here. Oh, that's because I've missed one of the substations, and like a Muppet. There's one just sitting there. I know you're all screaming at me. Oy, 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 oy. So I'll actually put that one in there, and we'll add 11 on. So what did I say that gave me? So that was 20, 28, 35, 43, 53, 60, and include that one would be 71, which would give me B as my correct answer. Duh. Couldn't see the trees for the substations. Okay, so question number 6. 4 graphs are shown below. How many of these graphs are planar? Now, for it to be planar, there can be no edges that cross. So you've got to basically think of them as elastic bands and stretch them over. Whoops, he says doing that. So let's see. Let's get rid of this one here. That's going to stretch over there. And this one here is going to stretch over there. And so that means there are no crosses now. So that graph there is planar. That one definitely is planar. And we can already see that. All right, so let's see. This one, let's get rid of that line there. That's going to cross over here. Let's get rid of that one there. That's going to cross over there. And now there are absolutely no crossing overs, all right? Because we basically have this, 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 and this. That's a terrible highlighting, by the way, but none of those. So they are, in fact, planar. Let's see whether this one can also become planar. Nope, that one disappears there. Let's put this one there. Can I stretch any of them others over? Nope. And so unfortunately what I'm noticing is that that will still cross there. So that one isn't, and in which case D would be my correct answer, with 3 of them being planar. Okay, having done some prep work for this already, what I've already worked out is the number of connections on the vertex, or the number of degrees, and I've drawn my diagram. So fingers crossed this diagram is right, actually. So we're trying to find which one is not true, having got this. So all I've done is taken that diagram there, or that adjacency matrix, and turned it into a diagram with loops and all sorts of stuff. We're trying to find out which one isn't true. The graph is connected. Well, that is definitely connected, all right, because we can see that all the points are connected. So that's true, and as is not helpful for the question. The graph contains an Eulerian trail. So, reviewing my notes, an Eulerian trail has exactly 2 vertices with an odd degree. Well, let's have a check. There's an odd degree. There is an odd degree. All the rest of them are even. So it does have an Eulerian trail. So that is no use to me. Eulerian circuit, again, let's have a look at my notes. An Eulerian circle is connected and has vertices that all have an even degree. Well, the vertices there don't all have an even degree, so that isn't true. I'm just going to leave that there for question part C. The graph contains a Hamiltonian cycle. A Hamiltonian cycle is a Hamiltonian path, every vertex that starts and ends at the same vertex. Again, I am not sitting there having a go at that one. Yeah, so let's just say again, what does that one? Hamiltonian cycle is a Hamiltonian path that visits every graph of the vertex that starts and ends at the same vertex. I mean, to be fair, guys, knock yourself out. You can have a go at that one if you want. The graphs contain a loop and multiple edges. Well, that's obviously true, so we get rid of that. So in that situation, it'd be between C and D. But if I had my summary book, which I do, or the textbook, and it says there an Eulerian circuit, what did I say again? Has to have all vertices that have an even degree. Ka-ching. That wasn't true of that one at all. Question number 8. A landscape gardener is planning the construction of a garden. This project requires 13 activities, I to U. Of course it does. The directed graph below shows each of these activities represented by edges. The number on the edges are the duration of the activities in days. The cost of reducing the completion time of any activity in this project Great, we're going to go crashing as well. Now, bearing in mind, these last questions are meant to challenge. They are really there for the people trying to get that very, very high 40s or 50s, because you lose a mark on these questions, and sadly with further maths you start to plummet down the rankings. The landscape gardener has a maximum of 3,000 to spend on reducing the minimum completion time of the project. Okay, so that means realistically speaking he can only reduce these by 3 days. The total completion time of the project can be reduced by 3 days. There we go. So they've told you 3 days. They're just confirming by reducing activity K by 1 day and activity Q by 2 days. So the first thing I've got to do is I've got to have a look at my completion times, right? So I've got to do that forward scanning and backwards scanning stuff. Now, I'm going to do that now and then come back because this takes a long time. Okay, so now having drawn this with my forwards and backwards scanning, and I've marked on my critical path. Now you may look at this, go, hold on a moment, those aren't on the vertices. No, I know, and I love the Cambridge textbook, and that is certainly one way of doing it, but a colleague of mine actually showed me how it might make more sense by doing them on the edges. All right, I know different textbooks do different things, but anyway, irrelevant. The point of this is that because this is crashing, we're looking at the critical path. And I do this in a pretty funky way, in the sense of what I'm trying to do is I realize the critical path is actually the longest path through that network. That's the critical path. It's the longest path through the network. So when you add up the critical path, and if I was to add together K and N and Q and T and U, that's what gives me the 23. So by all means, what we need to do then is reduce. When we're crashing, we're reducing or trying to reduce the length of the critical path. And in this situation, they want to reduce it by 3 days, which would make that hopefully 20 days. But when we're crashing, we have to be careful that when we reduce each of the individual activity times, that we don't create a new critical path. And that's what we're checking for every single time we do this. We're not creating a new critical path. Okay, so what I now do is I work my way around my diagram and I try and find out whether there could be a new critical path. Well, the first thing, let's just check the length here. 5, 6, I'm just adding the lengths, it's 6, 11, no, 4, sorry, add that again. Oh. So what I'm now going to do is work around and just check where my new critical paths will be. And there's lots of different ways of doing this. I tend to do it with a highlighter. So 4, 5, just adding the lengths together. 5, that's 10, and there's 9. So there's 19. All right, so going that way on my old critical path, 19. Now, if there's any other way to get between the start and that point there, that's before U1, that takes longer than 19, then I'm stuffed. Because by making the change in part A, I then created a new critical path. And as it turns out, shortcutting this video, what happens is that becomes 4, 5, then I add on the 8, which gives me 13, 19 and 20. So that path there actually would become my new critical path. So in that situation, A would not be the correct answer. So now we're going to look and say, well, okay, B. And again, if you know a quicker way of doing this, please, please, please let me know in the comments below. Reduce activity K by 2 days, so that now becomes 3, and activity Q by 1 day, that becomes 6. All right, so again, let's go around our diagram. So we've got 3, 4, 10, 19. All right, so that one stays as 19. Can I get between those 2 points in any other way? Well, as I work my way around my diagram, and guys, there are lots of ways around it to get between those points, up here and down there, up and around there, and up and around here, and up and down here. There are lots of them, but as I work through this, and again, this is the last question, it's trying to give you that 1 mark, and I would have left this till the end of the exam and come back and done it if I had time. And as it turns out, B is the correct answer, because if you work through all of the rest of those questions, then basically B is the one that actually reduces the time by 3 days without creating a new critical path. Now, a colleague of mine actually does it in a slightly different way, and I'll start it off by showing you how he does it, and then, but it's long. What he does is he goes, well, let's look at all the different routes between the start and the finish. And so I could have I to L to O to S to U. And basically does all the lengths in between those. Let's change color. So it goes 2, 4, 6, 1, and 1. And then adds all those together. 2, so what that would give me? 6, 12, 13, 14. So that would give me a path of 14. And then he goes, well, okay, that's one of them. Now I'm going to do no, let's not do I. I've just done that one. There's no other path that can contain I. So then you could J to M to O to S to U. And there could be J to P to U. And basically list them all out. And there's about 7 of them. I think there's 7 or 8 different routes. And then by the time he's done that, he looks for the path that's the longest. And that's the critical path. Okay, and one of these obviously would come out with 23, the K, N, Q, T, and U. Did I just say K, N, Q, T, and U? Yeah. So having done that, then what he will do is he will then go back through all of these and reduce all of them to try and find out whether a new critical path would be gained and which one would then change. All right, it's time consuming, but to be perfectly honest with you, no more time consuming. It might be slightly less than forward scanning and backward scanning and all those type of things. But again, remember that these questions here are really making you work for that 1 mark. Okay, let's move on to the geometry and measurement section. Here is question 1. A piece of cardboard is shown in the diagram below. The area of the cardboard in square centimeters is, well, to me, what I'm going to do is I'm actually going to work out the area of that little square there, which we know is 1 centimeter by 1 centimeter. So that has an area of 1 centimeter squared. That's got 1 centimeter squared. That has 1 centimeter squared, and that has 1 centimeter squared. Why is this important to me? Because what I'm then going to do is I'm going to consider and actually say, well, let's work out the whole of that, what would it be, square, and then take away the area of the 4 bits we've cut away. So we know that that's 5 by 5, which gives me 25. I'm going to take away the 4 corners, which gives me 21 centimeters squared. Just making sure this fits nicely, which gives me C as my correct answer. And question 2, which of the following locations is closest to the Greenwich meridian? Here is my Greenwich, there we go, there is my equator, and there is the Greenwich meridian, which actually passes through Greenwich. Okay, so here is 0 degrees. And what do we want? Well, we notice that because we're looking for the closest, we could look at it, maybe they're going to try and trick us, maybe they're trying to do it by longitude. I don't think they are, because what we notice is all of these values here are 32 degrees south. Okay, so what we're looking for is we know that movements this way are east and movements that way are west. Right, which of the following locations is closest? So we've got 40 degrees east, 80 degrees east, 60 degrees west, and then 120 degrees east and west is actually taking me around the back of the planet and not passing through Greenwich at all. And so I reckon the correct answer is A, that 40 degrees. And as it turns out, A is the correct answer. A waterfall in a national park is 4 kilometers east of a campsite. So there we go. So there's my campsite. There is my waterfall. A lookout tower is 4 kilometers south of the waterfall. So what do we know here? That distance there is 4 kilometers east of a campsite. Lookout tower, there's my lookout tower, is 4 kilometers south of the waterfall. The bearing of the campsite from the lookout tower is, now, I know that we can find this angle here. Well, now we could use tan if we wanted to. I mean, we've got an opposite here, we've got an adjacent. And using my calculator, I would actually find out that that angle there is 45 degrees. That angle there is 45 degrees. Now, we can't be tricked by the question, as I just have been tricked by the question. The bearing of the campsite from the lookout tower were actually here. So from the lookout tower makes me want to find that bearing there. Well, okay, we know that that angle there is 45 degrees. It just so happens the angle I've got there with the dot is 45 degrees. Because angles in a whole circle make 360, but I'm not going the whole angle, I'm going to take away that 45 degrees, gives me an answer of 315 degrees. E is my correct answer. So don't get tricked. It's that bearing of the campsite from the lookout tower. They wanted you to be tricked and actually find this angle here, which is what I did a moment ago because I didn't read the question. Okay, now question 4. A pizza is in the shape of a circle, has been cut into 12 equal slices. The area of the top surface of one slice is 9.42 centimeters squared as shown in the diagram. The perimeter of the top surface. So what they want you to do here is actually find the perimeter. This was a bit of a tricky question. I've actually done this question twice already because I keep misreading the question. I'm such a muppet. All right, so how is this going to help us? Well, the first thing we need to do is we actually need to find the length of this bit here. How do I do that? Well, I'm going to find the length or the circumference of the whole circle. That will then allow me to find this little bit here, and then I can add on those two lines there. Why? How do I know what they are? Well, they are my radii. So if I can find the radius, I can find the circumference. So we know the area of one slice is 9.42. So I know the area of the whole circle is 9.42 times 12. So 9.42, and we're going to times that by 12 on my CAS to give me 113.04 centimeters squared. How does that help me? We know that that's equal to pi r squared. So we know that pi r squared now gives me 113.04, which is going to help me find my radius. So the first thing I'm going to do now is divide that by my value of pi. And then I'm going to square root my answer. So hopefully this is all in your summary books to tell you how to do that. So the radius there is 5.99848. Now my advice is do not round. You don't need to round. Your calculator can remember all these values, and you may end up getting the wrong answer by bad rounding. So that's the radius. How is that going to help me now? Well, remember, I'm using that to find the whole circumference of that circle. So the circumference is equal to 2 times pi times the radius. So I'm going to do 2 times pi. Where's my times my radius? Now that's value there. I can just copy that down. And that gives me the circumference is 37.6896. That's the circumference of the whole circle. I want the whole circle. I'm going to divide that by 12 to give me just one bit. So all that working out, believe it or not, has just found that there, 3.1408. Is that my answer? No, because what do I now need to do? I've got to add on 2 of my radiuses here. So I'm now going to add on to that. What was my radius? 5.988. And I'm going to add on another value, hit enter, 15.1378, which happens to be closest to 15.14, and that gives me B as my correct answer. Read the question, that was weird. Okay, question number 5. The cities of Lima and Washington, D.C. have the same longitude of 77 degrees. Okay, useful to know. Now remember, longitudes are all great circles. This is going to come in handy in a moment. The shortest great circle distance between Lima and Washington, D.C. is 5697 kilometers. Assume the radius has, the Earth is radius that. Lima has a latitude of 12 degrees south and is located due south of Washington, D.C. What is the latitude of Washington, D.C.? Now, this is a pretty funky question. So what I'm going to do is I'm going to try and draw a sphere. And there is my 77 degrees. And we know that we've got our equator coming around there. All right, 0 degrees. Now what we happen to know is here's the center of my Earth. We know that Washington, I'm going to suggest, is somewhere there. And Lima is somewhere down there. Now the question is telling us that this distance here is basically 5697 kilometers. All right, 5697 kilometers. We know that we can actually join and the center of the Earth there with those 2 points there. Why is it going to be important to me? Because what they've really given me here is an arc length. So this question is about arc length. And what they've told me is that if we look at the angle there, that's 12 degrees, right? So the angle is 12 degrees from the equator down to Lima. We're going to try and find this angle here, which is going to give me from the equator up to Washington. How are we going to do that? As I say, it's an arc length question. If you remember, when we have an arc length of S and theta, then we can actually find all other pieces of information. So firing up my summary book, what did I get? I got that my arc length, which was given by S, is equal to pi times the radius times the angle divided by 180 degrees. And you can probably see that I've already got all these calculations on there. So what do we know? We know S is my arc length. They gave me that. 5697 is equal to pi, which is a button on my calculator. The radius is 6,400. The angle I'm trying to find, right? They've given me that 12 degrees. They've only given me part of it. And then we know that we're going to divide that by 180 degrees. And so as we can see on my calculator here, barring that line there, which I will now delete that one because that doesn't make any sense, is this. So what I've done is I have first off multiplied 5697 by 180 to give me just the pi times 6400 times theta. That gave me a very big number. And again, that E6 is standard form. So if you're not sure what that means, you need to look that up because it comes up. I've divided it by pi. I've divided by 6,000 for then divided that answer by 6,400. What that then did was gave me the theta on its own, which gave me, therefore we knew that the angle inside that whole section there, that angle there is 51.0022 degrees. We knew that Lima was down here at 12 degrees. So if I then take away my 12, I find out that this angle here is 39 degrees and it is north of my equator. And so A is my correct answer. Question number 6, a cake in the shape of 3 cylindrical sections is shown in the diagram below. Each section of the cake has a height of 8 centimeters as shown in the diagram. The middle section of the cake B has twice the volume of the top section, and the bottom section of the cake C has twice the volume of the middle section of the cake. The volume of the top section is 900 centimeters cubed. Wow! All right, so the volume of the top section is 900 centimeters cubed, right? Okay, so that's 900 centimeters cubed. What do I then work out? Well, I can say that that gives me a area of, so 900, oops, here goes again with the calculator, 900 divided by 8. You think moving the keyboard would be easier? All right, so that's my area, and I know my area is pi r squared, so what I'm going to do is I'm going to divide that by pi, and I'm going to square root my answer. Why? Because that's going to give me the radius of that top section. All right, so the radius of that top section is 5.98. That's my radius of that top section. Now the reason I'm doing this is because the question says what is the diameter of the bottom section of the cake C. All right, so what do we know then? It says then that the middle section has twice the volume of the top section. So we now know that that's 1,800 centimeters cubed. All right. It has a depth of 8 centimeters again, so I'm just going to follow the same working out. So again, now I'm going to do 1,800. I'm going to divide that by 8, so that's going to give me the area of that top section. I'm going to divide that by pi. He says hitting the wrong button. And then I'm going to divide, then I'm going to square root my answer, which now gives me the radius of that top section as 8.46. Did I need to do this? Probably not, to be brutally honest with you, because this intermediate section was of no use to me at all. So actually, I didn't need to do any of this, thinking about the question. What I really needed to do was the same idea, but I didn't need to work out this radius. I didn't need to work out this radius. Not reading the question, I thought they were asking me about ratios. They're actually not. So what do we know now? The volume. The bottom section of the cake C has twice the volume of the middle section. So 1,800, 18 is going to be 3,600 centimeters cubed. And now we can find the radius, which will then help me find the diameter. So let's do that then. 3,600. I'm going to divide that by 8. I'm going to divide that by pi. And then I'm going to square root my answer. And there is my radius. So the radius of that part of the question is 11.9683. I'm going to double that. So let's times that by 2. And that's going to give me 24 centimeters roughly. So question 6, is the answer C? It is C. 2 similar right angle triangles are shown in the diagram below. The total perimeter of the 2 triangles is, all right. So looking at this, we know that if they're similar triangles, they have effectively been doubled. Now, how is that going to help me with this? Well, we know that this is 12 meters long here. And looking at the ratios of this, I know that this is going to take 2 sections of that, and this is going to take 1 additional section, i.e. we can effectively split this into thirds. I'm going to tell you now, 100%, that the 12 is split into 3 sections, which is 4. So that's going to be 4 meters. And that's going to be 8 meters, which also works. You could even do this by trial and error. We know that that's going to work there. How are we now going to do the rest of this? Well, we can use some Pythag. First things first, I know that this here is a 3, 4, 5 triangle. So I know that that's going to be 5. And because the second triangle has been made twice as big, I know that that length there will be twice as big as well. How do I now work this out? Well, I'm going to do 3 plus 5 plus 10 plus 6 plus 12. Can I do these in my head? 8, 18, 24, 36. So hopefully my correct answer for 7 is C, and referring to my notes, it is C. There you go. So that was a little bit of Pythag, a little bit of ratio. Okay, this question is a ratio and volumes question. A young tree is protected by a tree guard in the shape of a square-based pyramid. The height of the tree guard is 54 centimeters. Right, that's what they've given me here, 54 centimeters. The top section of the tree guard is removed along the dotted line to allow the tree to grow. Removing this top section decreases the height to 45 centimeters. The ratio of the volume of the tree guard that is removed to the volume of the tree guard that remains. Because this is a similarity question, what I did then was draw my tree guard that's been removed, right? So they're removing this section here. We know the whole height is 54. So let's say that that has a volume of V, right? Again, we don't need to know, we can't actually work out the volume, we'll just say the volume of V. Because we know that the height that's left is 9 centimeters, we know that the ratio of the scale volumes, the ratio of the volume is going to be equal to the ratio of the difference in heights cubed. All right, so again, this is all summary from summary books. So what I now know is that because this was 54 and this was 9, I know that my scale factor is going to be 9 on 54. So that's my scale factor of reduction. Yes, I've gone from 54 to 9. We're going that way. Yes, happy with that? Cool. So knowing that, I can work out that the volume of this section here, the volume, because this is my scale factor, is equal to 9 on 54 cubed times my original volume, all right? It can't be 54 on 9 because that would actually make it much, much bigger, all right? So again, because we're making it smaller number over the bigger number. So that there is 9 on 54 cubed times the volume. So that's for the smaller pyramid. What do they want? They want the ratio of the tree guard that is removed, all right? So the tree guard that's removed. So we now know that the volume of the tree guard that's removed is 9 on 54 cubed times the velocity, times the volume. And we're going to try and find that ratio to the volume of the tree guard that remains. Now, bearing in mind what remains is, well, originally it had a volume of V, and we are removing that volume there. So we have to do the volume minus 9 on 54 cubed times my volume, right? So this is what was originally there. That's what we're taking away, and in which case that's what's going to be left. That's what the question's asking for. Now this looks complicated, but again, it isn't. The V's can all cancel. They will become 1s. So I get 9 on 54 cubed to a ratio of 1 minus 9 on 54 cubed. Now, as you can see on my calculator, I've already worked out what 9 on 54 cubed was. I had to change my calculator settings because it was all in flipping decimals. So 9 on 54 cubed gave me 1 on 216. Now, when I did 1 minus 9 on 54 cubed, that gave me 215 on 216. And what we know for that is that I can effectively cancel those out because they effectively cancel each other out, giving me, I have a ratio of 1 to 215, giving me D as my correct answer. Graphs and relations. Question number 1, the graph below shows the temperature in degrees Celsius over 24 hours. The difference between the highest and lowest temperatures on this day in degrees Celsius is closest to. I always mess these questions up. I always misread my scale, and that's going to annoy me. So let's say the difference between the highest and the lowest temperature on this day. So I'm going to zoom in to make sure that I know where my lowest temperature was. My lowest temperature was here. Making sure that we read the scale properly. They do not go up in 1s, they're going up in 2s. So that's 4. And my highest would be here at 32. So with any luck, if I do 32 minus 4, I get 28, which gives me D as the correct answer. Very embarrassed that I think it was last year I did an exam paper. The very first question, I got so overconfident, I was like, yeah, I can do this, and stuffed it up. Two straight lines have those equations. These lines have one point of intersection. They have a solution. Another line that also passes through this point of intersection has the equation. Well, the first thing we need to do is find that point of intersection. How am I going to do that? Well, let's fire up my calculator. I'm going to clear everything that was already there. And let's do menu, algebra, solve system of equations, solve system of equations. I've got two equations, ka-ching. Right, so what do we want? We want 3x minus 2y equals 3. That's my first equation. And my second equation is minus 2x plus 5y equals 9. Hit enter, and lo and behold, we get the value that x is equal to 3 and y is equal to 3. Now, we can do this through a process of elimination, but I'm fairly sure it's clear, hopefully, that B is going to be my correct answer because my y value and my x value are exactly the same. Well, there we go. So B is my correct answer. The graph below shows a relationship between x and y. The rule that represents this relationship between x and y is... Okay, let's have a look and see what we come... Oh, we got an x squared. So first things first, we know that this has the y... Oh, interesting. We have y equals my gradient times x squared. Always a good idea to make sure you look at that there, all right? So because they want us to be able to do this properly, he says, I'm actually just talking now because I'm thinking. All right, what am I going to do now? I'm going to find my gradient. How do I find my gradient? Let's zoom in and find a point that it seems to cross through nicely. Well, I'm going to go here and here. How do we find the gradient? We find it with a rise over run. All right, so let's see. We've got our rise of 4. We have a run of 6. And so I would know, therefore, that my gradient is going to be 4 on 6, which equals 2/3. Right, now, why is it positive or negative? It's positive because it's sloping up. So therefore, my equation of my line would be 2/3 x squared. Do we have a 2/3 x squared here? We do. We have C. So question number 3, C, was the correct answer. Okay, question number question number 4. A sheep has X cows and Y sheep. All right, on this farm there are always at least twice as many sheep as there are cows. Now, that means that I've always got to have twice as many sheep as there are cows. So now, counterintuitive, I'm take the cows and multiply it by 2, and I've got my sheep here. All right. Now, there's got to be at least, so it's got to be an inequality with an equal sign, twice as many sheep as cows. So that must mean that the value of this must be, the number of sheep must be always greater than equal to the 2 times the cows, yeah, because it's got to be at least. So that means the value of y can be bigger. And so in which case, let's look for that one there. Is that there? No, it isn't. All right, so let's see. What can we do? Well, if I divide both sides by 2, I get y divided by 2 is greater than or equal to x. Is that there? Nope. But if I flip it around, and by that I mean literally write it the other way around, then I actually end up with A as my correct answer. And I'll be honest with you guys, I hate these questions with a passion. All right, the revenue R in dollars that the company receives from selling end caps is given by the equation there. The graph of this revenue equation contains 2 straight lines that intersect at the point where n equals 1,000. Thank you. What is the value of C in this revenue equation? Right, now what we know is when they intersect, they have the same point. So we know that for the value of n as 1,000, they end up with the same equations. So we know that 25m would equal to 20n plus c. So I can take away 20n from both sides to give me 5n is equal to c. And because at that one point n 1,000 where they are equal, all right, so this only works when they equal 1,000. They tell you that in the question. So c would equal 5,000 because I would do 5 times 1,000, giving me E as my correct answer. All right, a bit of a trick question there, just because it's about knowing that at one particular point on the graph, the values of the X and the Y are the same. Question 6. In January 2018, an online shop had 260 customer accounts. In June 2018, the shop had 500 customer accounts. Woo, I wish. The graph below shows the number of customer accounts A with the online shop in months after January 2018 for a period of 10 months. Okay, so I'm just going to write something down here because they do this to me all the time. 260, so that's going to be January. And that's going to be June. Oh no, this is June. January, February, March, April, May, June. See, we know that June is the 6th month. Do you see what they tried to do there? Tried to trick us. All right, for a period of time. The growth in the number of customer accounts that this graph shows is expected to continue beyond the 10 months following the same trend. How many customer accounts can the online shop expect to have at the end of December 2019, where n equals 23? Right, so first things first, let's try and create an equation for this. So we've got, first things first, we know that we can do y, so what's this? A is equal to m times n plus c. Now again, all I've written here is the y, all I've done is written y equals mx plus c. That's the equation of a straight line, but we know that here our y value is a and our x value is n. All right, so I can just do that. I know the value of c because the c is my intercept, and they told me that in the question. They actually told me that in January it was 260 customers. So I now know that a is equal to plus 260. What is the value of my gradient? Right, well, we just choose 2 points that they've given us, and again, they gave us 2 points. It's best to use those 2 points. So we know that this was one of the points and that was another one, so we can draw a right angle triangle between them. So we know that it's 1, 2, 3, 4, 5 as my run, and my rise has gone from 260 to 500, which is 240. So putting that into my calculator, 240 divided by 5 gives me 48. So there we go. So we now have my equation A equals 48n plus 260. How many customer accounts can the online shop expect? And they gave you the value of n as 23. So A now is going to be equal to 48 times 23 plus 260. So 48 times 23 plus 260 is equal to 1364. A is my correct answer. All right, question 7. The shaded area in the graph below represents a feasible region for a linear programming problem. The maximum value of the objective function occurs at. Now, obviously, we could use the sliding line principle. Very difficult here because I don't have a sliding line. But we know that we can rearrange this equation here to look at the gradient of my objective function. So we know that z is equal to minus 2x minus 2y. Well, to find the gradient of the line, I'm going to replace or move the y over. Well, the 2y over to give me 2y, and I'm going to move the z over here, is equal to minus 2x minus z. Divide everything by 2 gives me y is equal to minus x minus z on 2. Now, why is that important to me? Because the gradient actually is what's important to me. So I know the gradient of my objective function is equal to minus 1. That's the gradient of my objective function. It's not z equals minus 1. So if I were to now slide this down, I'd be looking for points somewhere in there or along the lines where z equals minus 1. And as it turns out, what we actually can find out, or what we notice, simply because the intercepts are 10 and 10 and 5 and 5, is that both of those lines there have a gradient of minus 1. So both of those have a gradient of minus 1. So I suppose the question is, what are we now going to do? Well, because the question says we want the maximum value of the objective function, we then test points, right? And we need to be very, very careful here because they're trying to trick you. Because if I look at that point there, if I look at the lines BC, and any of those points along there, for example, if I take this point here of 10, 0, we know we've got that point there, 10, 0, then I know that the z, my value of my objective function along there is going to be minus 2 times x, so minus 2 times 10, minus 2 times 0, because my y value is 0. That's gone. So the points along there are all going to be minus 20, and we can check that point there as well, because it will give me exactly the same thing as minus 20. If we do the same here, with the value of 5 as x and y as 0, then what I get is my z-score is equal to negative 10. And you're going to say, yeah, well, then that means minus 20 is smaller, because again, remember, minus 10 is actually bigger than minus 20. And so if we now look along there, the point C only, nope, Any point along the line segment BC, we've just said no. Any point along the line segment AD is the correct answer. Any point along segment AB, definitely not, and DC, definitely not. All right, so there we go. So those are objective functions. Always a great idea to be able to use the idea of the Z and rearrange it to find the gradient and then see which points lie on that gradient. Jamie sold bottles of homemade lemonade to his neighbours on Saturday. The revenue in dollars he made from selling N bottles of lemonade is given by that. The cost in dollars for making N dollars of lemonade is that. The profit made by Jamie on Saturday could have been, oh, interesting, the revenue, all right, the profit. So the first thing I want to do is work out the profit is given by, so profit is equal to revenue minus the cost. So the profit, we don't actually know for the moment. So the revenue is 3.5N minus 60 minus N. Now you're going to say, why is it minus 60 minus N? Let's just not shortcut this then. Every single time. Minus 60 plus N. And remember, when you multiply out these brackets, this value here would become negative because that negative and that positive. So 3.5N minus 60 minus N gives me 2.5N minus 60. Ooh, how exciting. So that's going to be the profit based on N sales. All right, so that's going to be the profit based on N sales. The revenue in dollars he made from selling N bottles of lemonade is given by that. The cost in N dollars is given by that. The profit made by Jamie on Saturday could be. Very good question. So basically, we're now going to try and work out which of these numbers could actually give me a whole value of N. That's the only way I can think about doing this. So what we're going to do, so if we do 162, he says, no, calculator again, 162, I'm going to add 60 and divide that by 2.5. That gives me 88.8 bottles. No, let's do 165 minus 60 divided by 2.5. Gives me 42, and in which case I know for a fact that is the correct answer, because if you put in all the other values, 168 minus 60, and divide that by 2.5, you're going to get all decimal values, all right? So in that situation, it really wanted you just to trial and error and to check your value of N, knowing that profit was revenue minus cost. All right, ladies and gentlemen, that, I believe, is the end of this paper. It is indeed. Hopefully you found these useful. I'm going to work on the short answer questions in another video. All right, take care, guys. See you again.